Mm.
Good morning. Can you hear me? Hello. Check. 1, 2, 3, 3, 2, 1. Yatinder, can you hear me? Yes. Thank you. All are muted.
Sir.
You have muted everyone.
No, sir.
Please unmute people.
முன்னாடியே நம்ம போயிடுவோம்.
A very good morning to all the people who have joined in. We request you to keep your mics on mute, please. We'll be starting the session soon. Thank you. A very good morning to all the people who have joined us today for this training session on software-defined radio. I'm Shiva Shivkumar, the program coordinator with ISAC. I would like to tell you a brief about the Sainik Ranakshetra, which is an army hackathon which is happening, and all these trainings are a part of that. Sainik Ranakshetram is the Indian Army annual cyber security hackathon organized by the Military College of Telecommunication Engineering, Rashtriya Raksha University and Information Sharing and Analysis Center. It's a battlefield where you can prove your cybersecurity skills to defend your country from cyber attacks. As a part of this hackathon, free hands-on workshops are conducted to upskill the participants for competing. So get started by attending these free workshops from the mentors. Undergraduates, Indian engineering students and defense personnel can apply for this hackathon. It's a free event and one will be issued a certificate of participation when they reach the final level. There is an opportunity to win prize worth 15 lakhs and national recognition to the winners. The registrations for the hackathon are open till November 10th. You can also interact with our mentors in our community forums and also attend free workshops to upskill yourself. Now I invite the Director of ISAC, Group Captain P. Anand Naidu, to address the gathering. Over to you, sir.
Very much. Good morning, Shrikant. Will you please? Yes, thank you very much. I think that was causing a little disturbance. Very good morning to everyone on behalf of Rashtriya Raksha University and ISAC. This event is Sainya Ranakshetram, being organized by the Indian Army. The objective is talent search in the cyber security. We have, as organizers, as part of conducting bodies, RRU and ISAC have been making a lot of efforts to spread the message around as far as this hackathon is concerned. The registrations are open. Workshops are being conducted every week. We request all of you who are present here to also spread the message around to make sure that the students who are your friends, maybe colleagues, maybe in the same college, or friends who have been in the classes, class 12th, 11th or 10th together, but now studying somewhere else, you may please spread this message in your groups, in your networks, so that more and more people are coming forward, because the requirement is for the army. The army wants to identify good cybersecurity professionals. The people who are going to reach certain levels are going to get internships with the Indian Army. They are going to be recognized exclusively. There are a lot of things are on offer as far as this Sainya Ranakshetram hackathon is concerned. Now this hackathon is annual event. As you would have seen on the website, as well as you would have been told earlier also, that there are 3 levels and also 3 particular domains in which this hackathon is being conducted. Now, what workshop we are having today, as we would have on all Wednesdays, and we have been having for the last 3 Wednesdays also, is on SDR, software defined radio. This technology apparently new, but it's already in vogue at many places. We have the speaker, Mr. Karthik. He is the Chief Technology Officer with ISAC, and he is also one of the founder directors of CyberRange, the CyberRange Cybersecurity Labs company. So he is an expert in this particular field. He would be here to share his views and thoughts. Please make best use of this workshop to understand, clarify doubts if any, and also we would request you to visit the Sainya Ranakshetram website once a while so that you get to know the updates as far as the hackathon is concerned. That's 1. 2, also those of you who have registered, fantastic. If you have not registered but only attending this workshop, we request you to please register for the hackathon so that you are also part of the mega event that is taking place. Ladies and gentlemen, this event is about contributing to the national security by being part of this hackathon. We request you to please give a little serious thought, because there are far too many criminals, far too many state and non-state actors who are ready to attack us. We are almost the most favored destination for the cyber criminals for various reasons. One, the progress that the nation is making also is one of the reasons. Two, we are considered soft targets always. Three, we have been leaders in the IT and IT enabled services, and the world is not very comfortable with that fact that all these IT and IT enabled services, major companies are headed by Indians today. There is a requirement for all of us to pitch in. There is a requirement for all of us to make sure that the cyberspace is safe. If we are the leaders in IT and IT enabled services for almost 3 decades, why can't we be the leaders in the cyber security space? This is the question that we need to ask ourselves. Towards this, ISAC is making some minor contribution in capacity building. We conduct many training courses along with Rashtriya Raksha University. Those of you who are keen to undergo those courses and be part of the cyber force of the nation can visit the ISAC website. You will get to know various training courses, various free workshops, various free webinars that we conduct. We conduct, like for example, tomorrow we have a very important webinar which is talking about careers in the cyberspace, careers in cybersecurity. And the webinar is being addressed by the Senior Director of Cybersecurity of Accenture. He is the one who has coded the Norton antivirus software initially. And along with him will be the Chief Coordinating Officer of NEET, National Education Alliance for Technology of AICTE, Mr. Buddha Chandrasekhar. These are the two people who will be addressing tomorrow's webinar. So likewise, we have a lot of webinars, lot of hackathons, mini hackathons, lot of workshops. These are mostly, they are all free for you all to benefit. So I request all of you to visit the ISAC website also, to visit the RRU website as far as the hackathon is concerned. Of course, the Sanya Ranakshetra is the main website for this hackathon and all the events and news on this hackathon. Please do visit frequently, spread the message around in your networks. This is the least that I can request you to do, because we need more people to come forward towards this great cause. Thank you very much. Thank you all for being here this morning. Karthik, can you hear me? Karthik?
Yes, sir, I can hear you.
Good morning. Over to you,
Morning.
Karthik. Thank you very much. I think
Sure.
we have a lot of participants where they are ready to speak to you and hear you. Thank you very much.
Thank you. Thank you. Yeah, morning, everyone. Let me know if you are able to see my screen.
Yes, Karthik, we can see.
Great. Okay. So we'll start with some of the hackathon details itself. So the Senior Anakshetram, as Mr. Naidu and Shiva has introduced you to. We are specifically talking today about SDR, which is one of the streams in the entire hackathon. So the hackathon has a total of 3 streams. One is a CTF stream, one is the secure coding review, and the third one is the SDR, which is software defined radio. So the challenges will be simultaneously happening in all of these 3 streams. Typically, it is advised that as an individual, you may not be able to prepare for all of the streams. So you can, basically choose which one suits you best or which one suits your interest. And probably if you have come to this workshop, I assume that you are quite interested in SDR or participating in SDR. So you can register yourself in Sanya Ranakshetram, for the SDR hackathon. Once you register for hackathon, or once you decide yourself that you want to participate in the SDR hackathon, then so in these 3 streams or tracks, basically the SDR will again have 3 levels. Which will, the levels will start from November, mid of November, and it will go until the end of December. So each level will have a different cause or different way of testing you. The initial challenge, or the level 1 challenges, which will be on the mid of November, is mostly like a filtration round. So we are already seeing tens and thousands of participants coming in. So the first round will mostly contain MCQs, which will have some questions on, what is SDR, the basics of SDR, what are the different uses of SDR, and whatnot. So as I said, but the questions entirely will be on MCQs, and it'll have a specific time limit. The details of which you will get, or it will be communicated to you once you register yourself for the SDR. And once your registration goes through, you will receive a communication email, maybe within a week or so, saying that your registration is accepted. And then as I said, the mid of November, before the hackathon actually starts up, you will again receive an email with where you can actually participate, where you can register yourself, or where you should be able to log in to actually participate in the event. So once once you have cleared, or once you have passed the level 1, you will enter into level 2. So the level 2 will contain a little bit hands-on kind of challenges. And to give you a brief introduction to the SDR, first of all, before going to the level 2, level 3, I mean, for those of you who have no idea what SDR is, so can we have hands raised for those who are not at all aware of SDR, who are participating today? You can raise your hands. There is a function available. Okay. 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 There seems to be quite a few who are not aware of SDR at all. So what I'll do is I'll first talk about what is SDR, and what you can expect, or what you're supposed to do with SDR. Then I'll go to the details of level 2 and level 3. So again, if you're able to see my screen, then I'm just trying to show you an example of HackRF. Example of SDR. So SDR, it stands for Software Defined Radio. You might be aware, I'm sure everybody in the participants list today are aware of what a radio is, what an FM radio is, at least, right? So I'm sure you must be knowing, how your FM radio typically works, right? So there is a transmitter which is with the FM radio company, or whoever is hosting the radio channel, right? So let's say if you're talking about Big FM, or let's say Red FM, or something like that, so they will have an office where they will have a transmitter. So let's just show you how a transmitter looks like. I'm just looking, or searching for pictures which are apt. Okay, these are not the correct ones actually. Okay, so maybe this is how it would look like. So as you see, you will typically find a large tower with multiple antennas placed out. So it might be similar to what your 3G or 4G towers, but typically radio station equipment is a little bit higher. Usually your 3G or 4G towers are not that high. That long in distance, right? That height in distance. So usually your FM transmitters are very high, because they want to transmit the signal over cities. So which means if Hyderabad has one antenna, then it wants to transmit the same signal to at least 50 to 100 kilometers in range, right? So which means typically you will have a much larger antennas. So but if you see the so this is maybe an apt picture of an FM radio station. So you will typically have a large antenna which is capable of transmitting the signal to a much wide area. So this is typically how an FM transmitting antenna or something like that looks like. And even if you see the equipment will typically look like this. So there will be large racks which will be similar to your rack servers in a data center. But yeah, so they do have I mean, depending on how long they want to transmit, it is usually categorized into how much power it can actually push to the antenna. So usually you talk about in kilowatts, how much kilowatts you're actually transmitting to the antenna. So as you can see, there are 1 kilowatt to 3 kilowatt FM transmitters, which will have certain kind of range. So usually we talk about 10 kilowatts or 25 kilowatts, or sometimes if it is an AM band antenna, wherein you want to transmit the radio signals to hundreds and thousands of, not thousands of kilometers, but let's say hundreds of kilometers. So let's say you want to transmit the signal to about 500 kilometers in range, then you typically talk about 250 kilowatts or 300 kilowatts, or sometimes 100 kilowatts, depending on what frequency you are quite using. And then this is all on the transmitting part. And on the receiving part, that you have a very small device which can actually receive this, right? So that is something that you will find it in your mobile phone or your car, or on your homes with stereo equipment or something like that. So FM receiver is a very small antenna because it just has to catch the signals and it doesn't have to transmit anything. So there is not too much power that is required because the power is already being transmitted through the antenna. You just have to match the frequency and receive those signals. So this is typically how you have your FM transmitter and you have receiver, where you are able to communicate yourself with a radio signal. The other example that is common to everybody today is your Wi-Fi. So as you see, your Wi-Fi is also a radio transmitter and receiver kind of things, where most of your Android or iPhone mobiles today, they have the capability of both transmitting and receiving. So if you put your mobile phone in a hotspot mode, it means you are actually transmitting the Wi-Fi signals. Again, Wi-Fi is actually a two-way communication. So it's just a simple software that you have to write so that you are able to transmit the signals, or you are able to make it as a hotspot. So where you're primarily transmitting the signal, and if one of the device connects to your hotspot, then again it becomes a two-way communication, where you are able to transmit the signals as well as receive the signals. So the difference between your Wi-Fi or the FM radio is that FM radio is like, it can't transmit any signals. Your mobile or any FM radio that you have in your house, without tweaking the hardware, or without modifying the circuit of this FM radio, you will not be able to transmit any signals into it. So as you see, most of the equipment we use in our daily lives, like the Wi-Fi or the FM radio, the limitations that we have with this equipment is that if you take the example of FM radio, then it can only latch on to specific frequencies. So typically, if you have tuned the FM radio, you will start with somewhere around 87 megahertz or 88, somewhere around 80 megahertz, and you end at 108 or 110 megahertz at most. Right? So which means you will not be able to latch on to any other frequencies outside this boundary. And the same thing applies to your Wi-Fi. So you see that your Wi-Fi has specific frequencies, right? So for example, there is either a 2.4 gigahertz band or there is a 5 gigahertz band. So which means that it is logged on to that particular frequency, which means if you want to transmit something, or if you want to connect to 5.1 gigahertz or 5.2 gigahertz, that is not going to happen. I mean, you can't transmit or receive Wi-Fi signals on that frequency because your hardware has a limitation. And the same thing applies for 2.4 gigahertz Wi-Fi. So if you say 2.4 gigahertz, it only latches onto that 2.4 gigahertz. You can't actually transmit or receive something on 2.3 or 2.5 because your hardware actually doesn't support it, or your router doesn't have the capability of transmitting it on any other signal. And the reason why this functionality is not there is also a reason, because these frequencies are actually licensed, which means that there is a government agency almost in every country. I mean, all the 192 countries have some kind of limitations on what kind of frequencies you can use or what kind of frequencies you cannot use. So it's like, for example, in India we have a Ministry of Telecommunications which will cater to all the licensing part. So for the radio or for the FM radio transmission and receiving, you'll have to actually buy the license from the Ministry of Telecommunications, where you pay some amount to the government saying that I'm buying this license for a certain period of time. So usually you will take it for 5 years or 10 years or 15 years or 20 years, depending on how the government is actually allocating you to. So depending on country to country, you can buy a license for specific time period only. So, and you'll have to pay for it, which means that when you pay for it, it means that that license band belongs to you, and you will be able to transmit anything. And mind you, there is no license for receiving signals, but if you want to transmit something on a specific frequency, then if you do not pay the government, that local government in any country, then that transmission basically becomes illegal. So if somebody has already purchased that particular frequency, then they can actually legally sue you. So which means there will be a legal case on you, and there will be a civil liability on you, because you are transmitting on an unknown frequency. So whether whether this is an unlicensed band or a licensed band, without paying the government, you cannot actually transmit any signal. Or if you do want to transmit signal for research purposes, then it has a limit actually. So for example, if you are using if you are researching it in an office space, typically your office will give you some kind of Faraday cage, or some kind of limiting, wherein the rules are such a way that outside your house, your signal should not interfere with any signal that is outside of your house or outside of your office space. So which basically means that if you're placing, or if you're researching on transmitting some frequencies, it cannot go typically within 50 feet or 40 feet of the device, or it cannot go outside these bounds actually. So more than 50 feet, if you're transmitting any signal, that comes onto unlicensed or illegal transmission. So this is the reason why most of the licensed bands are fixed to a specific frequencies only. And now coming to what SDR basically means is that SDR gives you that ability to both transmit and receive the signal by changing a small program. So which means the SDRs that we are talking about, it gives you the ability where you can program this hardware, and you can either transform that into a transmitter, or you can transform that into a receiver. So it's just at the click of a button. So you just have to load a program which will automatically configure the device to either transmit or either receive a signal. And usually most of the SDRs that are available in the market, they have a wide frequency range. For example, if we check for RTL SDR, which is like the lowest level of SDR that is available on the market. So if you see the frequency, let me just check the frequencies here. Amazon Pay, I guess it is not listed out, but yeah. So if you just search Google for this, yeah, somebody says Bluetooth. Yeah, Bluetooth is also a great example. But as you see, almost all of these things that you have, you have been using or you have been aware, they're all like fixed bandwidth or fixed frequencies. SDR gives you that ability where you can modify the frequencies as you wish. Okay. Where is the frequency range? Okay. So I'm not able to find the correct specifications. Let me just check over here. But typically what happens is that the lowest of the RTL SDRs will have a frequency range of somewhere between 300 or 500 megahertz to up to 1.8 gigahertz or 1800 megahertz. That is the typical frequency for RTL SDR, which is a low cost one. So which means you can just buy it on Amazon.in or something like that. And if you want to tweak it to either transmit or receive the signals, you should be able to do it. Again, you'll have to first check whether this particular RTL SDR has that capability, because most of the low cost ones, which are less than 10,000 rupees or less than 7,000 rupees, they typically don't have the transmission capability. You can only listen to a lot of frequencies, but not actually transmit anything. But that is something that you will have to check with what SDR you are actually purchasing with. So you typically the lowest, low cost RTL SDRs will not have the capability of transmitting, but you will be able to listen to any signal that is between 500 megahertz or 300 megahertz to up to 1.8 gigahertz. So that is what an RTL SDR can do. So yeah, so you have some softwares called GNU Radio. So if you open GNU Radio or if you install GNU Radio on your system, and if you connect your RTL SDR with GNU Radio, then you will typically be able to sorry, you will typically be able to tweak the frequency and you will be able to listen to a much larger bandwidth. Let me just show you how that looks like. Okay. So GNU Radio software will typically looks like this. So as you can see, you will be able to set a frequency. So, I mean, as I said, the frequency range will be much larger. So from 500 megahertz or 300 megahertz, depending on what, what your SDR supports, you can go from 300 megahertz to up to 1.8 gigahertz. You will be able to latch onto any signal. So which means that, you'll be able to capture that signal at any frequency. And once you catch hold of that frequency, then GNU Radio will also help you out in actually decoding the signals correctly. So as you see, the FM transmission is typically, an audio signal that you are supposed to decode, right? So which means that, FM stands for frequency modulation. So you latch onto the correct frequency like 102.6 or, 101.4 or whatever it is. But once you latch onto that frequency, you will have to tell the GNU Radio that, you are expecting an audio output, right? So then you should be able to listen to the audio correctly. So, and then if you're talking about Bluetooth or, Wi-Fi or, something like that, first of all, most of the RTL SDRs will not have the capability to listen or transmit something on 2.4 gigahertz. So that is where HackRF comes into picture. So if you see, HackRF will look something like this, where you will have, an output which you can connect to an antenna. Again, depending on how you want to make this operate. So this is HackRF is a half duplex device, if I'm not wrong. Again, what is the difference between half duplex and a full duplex is that half duplex will, will only transmit or receive at once. So if you configure the device to transmit, it can only transmit. It can't actually receive something on the same frequency. So a full duplex device, which is much larger SDR, something like a Blade RF. So this is much more expensive actually. Yeah, so this will typically be much more expensive, but this will give you a full duplex device. Let me just show you Blade RF 2.0. We can just go to the shop. Yeah. So as you can see, typically it will cost you somewhere around $500, $720, and some of the bigger ones will cost you somewhere around $600. So that's like above 1 lakh. So typically you can get this Blade RF for around 60 or 70,000 if you want to import it to India. So custom duty, everything, antennas, everything. If you purchase, you will get it somewhere between 60 to 70,000 rupees. So, but within that, what you will be able to get is you will get a full duplex device, which means simultaneously, which means at a time you will be able to transmit as well as receive, which is what Wi-Fi does, right? Wi-Fi can Wi-Fi, Bluetooth, all of these data communication frequencies or these devices will have the ability to transmit and receive at the same time. So usually your Wi-Fi or Bluetooth, what it does is even though we say 2.4 gigahertz, so if you drill down to 2.4, which is 2400 gigahertz, the frequencies are now subdivided into megahertz. So which means that in 2.4 gigahertz range, let's say that 2.4.1 2.4, 2.4, 2.4.1 or 2.4.00.1 frequency can be used for transmitting something, and 24.2 or something like 2.4 or 2.43 can simultaneously be used to receive something. So the it will have a subdivision process where some megahertz will be given to transmission, some megahertz will be given to receiving the signals. So that is how on two different frequencies you are able to transmit and you are able to listen to it. So this SDR will give you the ability to actually transmit and receive signals at the same time. And if you see blade RF 2.4, this is a specific blade. It will help you listen to frequencies anywhere between 47 megahertz to 6 gigahertz. So which means it has a very wide range actually. So from lowest of frequencies like 47 megahertz, you can go up to 6 gigahertz range. So which means that again, these devices will also have something called as a daughter boards, which means if you want to listen to frequencies which are much less than 47 megahertz, like if you want to listen to 300 kilohertz or 500 kilohertz or 100 kilohertz frequencies, then you will also have a daughter boards which you can attach to this blade RF, which will enable you to listen to the lowest of the frequencies. And there are some SDRs which will be able to go or expand its range up to 12 gigahertz. So you will require something between 9 gigahertz to 12 gigahertz if you want to intercept satellite communications. So there are certain satellites which will also transmit on 5 gigahertz range and 6 gigahertz range. But most of the satellite communication, for example, if you want to latch onto the dish TV or your television broadcasting satellite signals, then you'll have to go for 9 to 12 gigahertz range, because your dish TV typically operates at around 10 gigahertz or 11 or sometimes 12 gigahertz. So if you want to intercept most of the satellites that are there, then you'll have to get those frequencies. And if you want to intercept GPS signals, or if you want to intercept some of the other types of signals which are like public, for example weather satellites. So if you want to intercept a weather satellite or something like that, you can do it with blade RF itself, because the frequencies transmitted are much lower. They are between this megahertz to 6 gigahertz range only. So they typically don't go above 6 gigahertz. So these weather satellites and all, you will be able to intercept using a simple blade RF. The only thing that you will require is that antenna. So depending on what kind of for example NOAA I'm just trying to show you the antenna that you'll have to build if you want to intercept the signal for a weather satellite. So this is something you can also do this in a DIA format. So you can just you just need some wires, and you just need to put it in this particular format. So if you have a blade RF and if you put an antenna in this format, you just have to put the wires in this way. If you arrange it in this particular way, then you will be able to listen to all the signals, or you'll be able to intercept the signals of the weather satellite, which is NOAA satellites, which is primarily deployed by US. So as you can see, it typically operates at 137.818 megahertz. But if you want to capture all the data, you will have to have the signal in this format. So typically, you can also use a radial antenna or omnidirectional antenna, but you might be missing a lot of signals over there. So as I said, you typically need to design yourself an antenna like this if you want to intercept the signals. So this is some of the common knowledge that you'll have to gain if you want to work with SDRs, or even if you want to participate in hackathon. You would want to know what are the different types of antennas that are available, and what kind of antennas will capture what kinds of signals, what are publicly available signals. So typically your hackathon will not have any satellite interception which is above 6 gigahertz. So you will not go above 6 gigahertz, but within 6 gigahertz range, whatever satellites or whatever antenna types you might have to use, you are expected to have that knowledge, right? Sorry. So typically you can configure your hack RF or your blade RF to make sure you are able to receive or transmit the signals also. So in any frequency, again, as I said, the transmitting of the signals you'll have to be very careful with. So if you are building a high powerful antenna and if you are putting it on the outdoors, so you have to make sure that there is no frequency you are using, which is on a licensed band. Because again, it changes between country to country. So what US might have a particular frequency which is in an unlicensed band range, but India might have already rented that out or leased that particular range to a specific company. So you'll have to check with Indian government, and the cheat list is, the list is already available with Ministry of Telecommunications. So you'll be able to know which are licensed bands inside the country. You have to make sure that if you're doing it for research purposes, you should not transmit, or your transmission signal should not exceed more than 50 to 100 feet. That is maximum. So if you cross this, then you are causing interference to your neighbors or people around your society, or it is also possible that you are interfering with their equipment to receive certain kind of signals. Again, as I said, that comes under an illegal transmission. So most probably if you want to transmit something, be very careful in doing so. Be double sure that you're transmitting on a signal which is completely in an unlicensed bands. So if it is an unlicensed band, typically you will not face any issues. But at the same time, as I said, so even in the unlicensed band, you are not supposed to create any interference to any nearby frequencies. So you also need to understand that frequencies are very sensitive. So which means if you're transmitting something on, let's say, 101.5, or not 101, let's say you take 150 megahertz, you're transmitting something on 150 megahertz. So depending on what kind of equipment you are using, it is possible that it is not only transmitting on 150, but there will be a crossover, which means you are accidentally transmitting on 149, 151, 152, 153 also. So depending on if your equipment is interference protected or not, depending on how you have made your antenna, whether you have used good quality materials, good quality capacitors or not, depending on various factors, you might not be transmitting only on a certain frequency. So you'll have to take care of that also, to make sure that you're not transmitting on any unlicensed, or you're not causing any interferences. So these are some of the disclaimers that I want to give to you, because after this session, for preparation of this hackathons, if you buy an RTL SDR, or if you want to use this to learn yourself, you have to make sure you take care of all of these things. Otherwise, you will land in trouble. I'll take some questions before I go to the actual level 2 and level 3 challenges. Okay. One of the questions says, okay, where is it? Yeah, will we need a walkie-talkie? No, you don't need a walkie-talkie. That will most probably not be part of your hackathon. But again, as I said, once you register, you will get more information on what is needed and what is not required. So there will be ample time given to you before level 1 or level 2 starts, wherein maybe they will inform you 1 week before or 10 days before if there is some change or some new challenges you are expected to. Okay, less frequency, more range. Again, it's not exactly true. You can't just say if you're operating on a less frequency, it gives you more range. It actually is not that. It depends on the wavelength and how much power you are actually putting up onto the antenna. So even if you are broadcasting on a less frequency, if you are pumping too much power into the antenna, then you can go long range. So higher frequency, it's not about range, but higher frequencies will require higher power, and obviously the range will automatically come down. But that analogy is not completely correct. So less frequency, more range. So higher frequencies will have LOS. LOS stands for line of sight. So if you're operating on a higher frequency, it means that the line of sight will be minimum, because frequency and wavelength are inversely proportional. So which means the higher the frequency, the smaller the wavelength goes. So which means if the wavelength is very small, then it means the transmission antenna and receiving antenna should be facing face to face. So if they are not face to face, then they will miss out the frequencies, which is why most of your dish TVs, that you'll have to point out to a specific angle. even if you deviate from that angle from a slight radius, so even if you deviate with a slight radius, you will not receive any television signals to you, right? That is because you are communicating, or if you are basically receiving the signal from a geostationary satellite. So which means that if a satellite is hovering above the Indian geospace, then it will always stay at a single point. That is how your dish TV, you are able to point it to a specific location or a specific angle, and then throughout the year, even though the Earth is actually rotating or revolving, the satellites are also revolving at the same speed, which means it's basically a geostationary satellite. So that is the reason, again, as you see, you are having face to face with the satellite. So the dish TV antenna and the satellite are actually facing face to face because it operates at a 12 gigahertz, and it is because a higher frequency requires line of sight, and the lower frequencies can can operate with a much lower frequencies will require large antennas. So the lower the frequency you go, the the antenna size will become much higher and higher. Otherwise you will not be able to capture the low frequencies. So for example, if anybody is from 90s or 2000s, you might be seeing something called as a Yagi antenna. So mostly in 90s and 2000s, Doordarshan or most of the channels were broadcasted in this format. So as you see, your typical television broadcasting signals, they go in lowest of megahertz, or sometimes in kilohertz range also, somewhere around 900 kilohertz, or sometimes 200 megahertz or 100 megahertz. So if you want to receive these signals, then you will have to have a large antenna which looks something like this. So if you don't have this antenna, you will not be able to receive the lowest signals. And if you want to go even further, then that is where you will need a much larger antennas. The lower the frequency is, the dish size will become larger and larger. So typically these radio astronomy astronomical antennas, they typically operate at a few kilohertz, or less than kilohertz actually. So it can operate at maybe 100 hertz, or 3000 hertz, or something like that. So if the frequency is much lower, then you will need a much larger dish antenna, so that you are capturing all of the necessary wavelength. Because as I said, if the frequency is lower, the wavelength will be higher. So the top end of the wavelength and the bottom end of the wavelength, you should be able to capture both of these things together. So if you want to capture the entire wavelength, then you need a much larger antenna, so that you're able to capture that. But again, as I said, the less frequency, more range is not exactly correct. You'll have to understand it correctly. So some more questions is, what does a dish TV antenna do? A dish TV antenna will only receive the signals. So as you see, it has something called as a line of sight. So it will be face to face with the satellite, and it will receive the signal somewhere between 11 gigahertz to 12 gigahertz. So whatever signals it will receive, you will basically decode it. So the 12 gigahertz frequency is first decoded onto much lower frequencies where the actual television signals are broadcasted. So as you see, whatever signal you switch on to, there are like some 300 or 400 channels, right? So all of the 400 channels data is actually being broadcasted at once. So you can select any channel and you will be able to decode only that particular signal. So that is how a dish antenna or your television actually works out. So but the satellite is actually transmitting all the channels at once. So the data that is required for all of these channels are being broadcasted at once. So that is why you require this 12 gigahertz, because on the 12 gigahertz, it is pumping a lot of data. So it is up to you which one you want to receive or which one you want to basically tune to. Yeah, that's what. If you want to send signal from country to country without government permission, then that becomes illegal. So if you want to send an audio signal or even a video signal from country to country, or very wide area on a wide area network, then you can do so with the help of a ham radio. So again, ham radio is also a licensed band. So if you want to transmit anything from country to country, you will most likely require a licensed band. If you want to do it without license, then be aware that governments can actually listen to where you're broadcasting from, and they will be able to pinpoint to your exact house location or your office location where you're broadcasting the location from. So that is very easy, and almost all state governments and central governments has this equipment. So the minute we detect some kind of unlicensed band transmission, they will roam around in a van, and within a few hours they will be able to pinpoint where the signal is coming from, and they will catch you and they will arrest you. That's what is going to happen if you are transmitting without permission. So there is no frequency range for unlicensed bands. What you'll have to do is you'll have to go to the Ministry of Telecommunications website. You'll have to find out what are the licensed bands. So they will list out what are all the licensed bands, which band has been allocated to which company, and then whatever is not being used, that is called as an unlicensed band. So again, as I said, even in an unlicensed band, there are restrictions on what you can transmit and what you can receive. So when a low-end RTL SDR can only receive, then why can't we use a simple receiver which has more range for listening? Again, you'll have to define what do you mean by a simple receiver. Thiru has asked this question, that if a low-end RTL SDR can only receive, why can't we use a simple receiver? So what is the kind of simple receiver you are talking about? RTL SDR itself is a receiver. So you can't use an FM radio, or you can't use your router to actually receive these signals, because it is just not capable of receiving a wide frequency signals. So they are basically locked to a specific frequency. So even if you're using an FM radio, as I said, without changing the hardware or without altering the hardware, so which means that you'll have to add additional hardware to your FM radio before you start listening to any. You can make your own RTL SDR, that is for sure. I mean, if you have the right components, then you can make your own RTL SDR, or you can make your own FM radio also. So you can typically get the components from your electronic store, and you can design your own FM radio or even a radio receiver, which can go for a wide band actually. So starting from 100 megahertz to up to usually typically less than gigahertz, you should be able to do it yourself. So if you want to do it much higher frequencies, then you typically need a complex circuit that you'll have to design to, which not everybody might be able to do it. But yes, it is DIY capable. So you can build a receiver in your home if you have the right electronics knowledge. Yeah. I mean, you don't have to buy any RTL SDR. Those who have cleared level 3 for Hackathon, they will be receiving a SDR which will be shipped to their homes. But at the same time, for level 2, there is no hardware requirement, because most of the challenges will be virtual. So even in that case, I would recommend, if you can afford some 6,000, 7,000 rupees, then I will definitely suggest you to buy a good RTL SDR, so that you can basically understand the concepts of the hackathon. So for those who are not at all aware of the SDR, for them I will definitely recommend you to buy the RTL SDR before you register before you start participating into the hackathon, because until unless you have the device on your hand and you actually start tweaking on that, you might not get the full knowledge of it. But I'll talk about level 2 and level 3 requirements shortly. Yeah, 700 to 1500 megahertz antenna is mostly sufficient. But yeah, as I said, the actual challenges will be given to you, on which you will be knowing more about what kind of antennas you are required. But I would say 700 to 58 megahertz is more than enough. So Arvind Har has said that I'm an absolute beginner. What resource could I use to learn for hackathon? So again, I've shown you some softwares, right? Like for example, GNU Radio. If you know how to use a Kali Linux operating system or a Linux operating system, there is an OS called Kali OS, which has all the SDR software inbuilt into it. So I'm just pasting some SDR projects that you can do. Or SDR. I'm just pasting some links which might help you out if you are an absolute beginner. Okay. So, okay. Yeah, I will talk about the format of this competition shortly. How can telecommunication department identify that someone is used an unlicensed frequency? As I said, there are equipment which can pinpoint where the transmitting signal is originating from. So that's again a different session I have to take in order to tell you how it is actually done. But you might have listened in movies that there is some principle called triangulation. So the triangulation is something that they typically use to find out where exactly you're transmitting from. What is a maximum transmission frequency and maximum receive frequency? Arya Shah, I'm not able to understand what is the exact question. Maximum transmission frequency for a specific SDR you are asking, or you're asking what you can transmit and what you can receive. So just give me a clarity. So Avinash has asked, can we use the white space frequency for transmission because they are unused? So is it illegal to use that spectrum? See, as I said, you can use the unlicensed band, but provided, you'll have to understand what are the local restrictions in India. So as I said, as long as you're not causing any interference, it is not considered illegal if you're transmitting on an unlicensed band. But as I said, it depends on how much interference you're actually causing. So if you're not actually causing any interference and if you're transmitting and receiving on an unlicensed band, most typically you will not land in any trouble. But it is up to the government. So just check for the local laws on how much power you can transmit with. Also, there is a regulation on for unlicensed bands. There is a regulation on how much power you can transmit with. So there are regulations for that. So first know those regulations and appropriately transmit it. So Sri Harsha has asked, what are S band and L bands? So they are just names given to a specific frequency bands. So if you see, so yeah, as you can see, S band, S band basically typically starts from 2 gigahertz, and it varies from 4 gigahertz. So the frequency range starts at 2 and ends at 4 gigahertz. So that's called an S band. So the names are typically given to identify or to commonly understand what kind of frequencies you're specifying about. So as you can see, L band typically refers to any frequency that you are transmitting or receiving between 1 to 2 gigahertz. That's it. So they are just names that are given to a different frequency ranges. So can we use, Prashant has asked us, sir, can we use RFID for same processor? I believe yes. I mean, RFID typically operates at 125 megahertz, if I'm not wrong. 125, 127 kilohertz or megahertz. I'm not exactly sure. I guess it is RFID frequency is in kilohertz only. High frequency. Okay. It's in megahertz only. So RFID is around 13 megahertz and around 233 megahertz, if I'm not wrong. So these are the two frequencies which are commonly used at RFID. So you'll have to make sure your HackRF or Blade RF or your SDR actually supports that low frequency. So typically most of the SDRs start at 300 megahertz, which means RFID you will not mostly be able to intercept with an SDR. So you'll have to buy a daughter card and then you have to attach it with the SDR in order to listen to these RFID frequencies. So simply increasing the size of the antenna will not exactly work for you. As I said, depending on the wavelength, depending on the frequency you are actually transmitting, there are antenna sizes that are required. So, so the antenna size and range is not like, directly proportional, or, there's not dependent on each other actually. So even for low transmission signal, if the wavelength is higher, you will have to have the large antenna size, even if the power is very low. So even if you want to listen to a low power frequency, but if you are using a low or higher wavelength, which is lower frequency, then you have to have a higher antenna. So that is what you need to understand. So depending on, as I said, again, depending on the use cases or depending on the applications of your frequency and frequency and the bandwidth that you are using, you will have to decide on which antenna is applicable for it. or which antenna you should use. And power is only to increase the range. So just increasing the antenna size will not increase the power or receiving capability. It can only make you get a better signal, but that doesn't mean that you are getting a higher power. Power has nothing to do with the size of the antenna. Actually, I mean, this Sriharsha has asked what is the link between information transmission and frequency, or more wavelength have more information. So it actually depends on how you are encoding the signals and decoding the signals. So typically higher frequency can have higher bandwidth, which is why we are moving from 2.4 gigahertz to 5 gigahertz, right? So the higher the frequency is, yes, you have the capability to transmit much higher information packets. So as you can see, your 5 gigahertz typically can transmit up to 2 Gbps of data. So theoretically, it can transmit somewhere around the 3.4 gigabits per second is what you can transmit on a 5 gigahertz signal. You can actually even get more. I'm not exactly sure. Yeah, on the lower frequencies, yes, you will not be able to transmit more of the signal. But again, there are a lot of other factors. It's not just dependent on frequency and wavelength. It depends on how you're encoding the signal, how you're how you're encoding, decoding the signal, how much bandwidth you're actually using, or how much bandwidth you actually have. So it depends on a lot of factors to determine how much data packets you can actually transmit or receive on a particular frequency band. What can we do in a free of cost related to SDR? Again, I don't understand this question, what you can do with a free of cost related to SDR. So maybe you can rephrase your question. So Daksh Kurana has asked, I'm not a graduate, not even in college. Can I join Hackathon? I have SDR and knowledge also. I'm not exactly sure. Since you have filled out the form, if there is any, if you cannot join, you will be communicated to accordingly. So I'm not a graduate. So typically the hackathon rules are that you'll be able to participate if you are in any college. So if you are a student, so maybe +2, or if you're in graduation, I guess you will be able to join the hackathon, or you have to be from a defense background in order to participate in the hackathon. If you are a working professional or any other freelancer, I don't think so you'll be able to join this. You have to prove yourself that you are a student somewhere in order to participate in the hackathon. So, okay. Yeah, so if you are in school, I'm not exactly sure. You please register. The team will let you know if you can compete or not. See, there is no maximum transmission frequency as regulated in India. So right from 100 kilohertz, or even I would say right from 1 hertz to up to 50 gigahertz. There are experimentations for 50 gigahertz. So there are licensed bands actually. So you have to look at the exact specific bands, and you should transmit in frequencies that are other than the licensed bands. So there is no maximum transmission frequency as such. So if you can transmit at, the experimentation goes up to 100 gigahertz. So there are, there are research which is going on which can transmit 100 gigahertz or 120 gigahertz also. But again, as I said, there is no maximum transmission frequency, and the higher the frequency is, as I said, it has to be in a line of sight. So above 12 gigahertz or above 8 gigahertz also, it's mostly line of sight. It doesn't even go in an omnidirectional, or at least it doesn't deviate actually. So most of the frequencies above 8 gigahertz, they will become directional. So which means the regulations will be much low if the transmission frequency is higher. So what algorithms are used to encrypt the signal? Again, I can't give you a straight answer for what algorithms are used to encrypt the signal. It depends on application to application. So can we make SDR antenna using electronic components? Yeah, absolutely. So you can make any type of antenna yourself. Yeah, I will talk about the level 2 and level 3 right now. I just have a few more questions. So can a broadcasting unit know how many listeners are listening to it? No, that might not be possible. How many people are listening to it is something that people will not be able to know. But if you're transmitting, yes, people will know. No, without spending any money in the sense, there are virtual simulations that you can use without spending any money. But I would say if you want to get good knowledge and good experience, you will have to spend at least some amount of money. So the lowest RTL SDR you will get is somewhere around 2,000 or 3,000 rupees. You can get it in an Amazon. Yeah. So if you check for the lowest RTL SDR, yeah, as you can see, there are RTL SDRs which comes around 3,900. There should be one RTL SDR which is like 2,000 rupees also. Yeah. So as you can see, there is an RTL SDR which will cost you 2,500. Including GST, it will cost you somewhere around 2,800. Yeah. So yeah, that's it, I guess. The lowest is less than 3,000. You'll have to at least buy that to get some experience or hands-on experience with an SDR, or how to work with SDR, or what are the different softwares you can use along with the SDR. Yes. So now no more questions. So I will go to level 2 and level 3. So level 2, as I said, it will have virtual questions, which means that the challenges will be mostly on PCAP captures or GNU radio captures. You should be working on these capture files. So you should have experience with Wireshark. You should have experience with GNU radio and some other related softwares. So wherein you should be able to know how to decode the Wireshark captures, or the signal captures, and then you should be able to decode them. You should be able to understand what kind of data that is present inside this code, whether it is an analog signal that you'll have to decode it to, or whether it is a digital signal is what you'll have to identify. So the level 2 challenges will be this kind of challenging, where mostly you will get some file that you'll have to decode. So all of the challenges in level 2 will be virtual only. There will be no hands-on SDR device that you will require with. And when it comes to level 3, you will be getting your hands on an SDR, which will be provided by the MCTE, which is the army. Actually, the Indian Army will ship out the SDRs to you, or that will be communicated later to you, whether you are supposed to come to the MCTE and participate, or whether you are supposed to whether the SDRs will be handed over to you. But in any case, level 3 is where you will get your hands on the hardware equipment, and the challenges will actually require you to configure a device. So it will either be a Lime SDR or it will be a HackRF. So you should be comfortable in operating both of these things. As I said, once you register yourself in the hackathon, more information will be communicated to you, saying which kind of device you'll have to prepare with. So there are challenges that could be like a proper hackathon, where there will be a theme, or there will be a task that will be given to you. You might have to program, or you might have to write an encoder or a decoder to transmit a particular signal, which means that there will be some kind of build task. You'll have to build something to achieve something. So there could be that kind of challenges in level 3, where you will be operating it on the SDR. And there could also be some challenges in level 3, where again you'll have to capture a particular signal. So I believe you are required to travel to some on-prem unit, where there will be some broadcast signals that you will have to receive, and then on the fly you will have to write a decoder or an decoder which will be able to decode that signals correctly. So this is the kind of challenges you can expect in level 3. So level 2 is completely virtual based challenges, and level 3 will be hardware, or hands-on challenges, which you'll have to tweak your SDR to either listen or to transmit these signals. So this is how the complexity of the challenges are going to be in level 2 and level 3. But when it comes to level 1 is mostly MCQ challenges only. So from which we will filter down participants who can go to level 2, and level 2 may whoever succeeds the top 5, top 3, whatever is decided by the management, will go to level 3. And obviously we will pick up the top participant from level 3. So that is how the hackathon will be conducted. So if you have any more queries, you let me know. If you are in school, I would say you apply. You register yourself in the hackathon even if you are still in school. If they consider, they might let you in. Because you're still a student. But I would say at least register yourself. So if you're not eligible, then at least they will inform you directly. It is not necessary, but it is recommended approach. If you can buy an RTL SDR, that is going to help you out in the long run also. If you are interested in pursuing the SDR, or if you're interested in radio communications or electronics, then I would definitely recommend you to buy one RTL SDR. For hackathon, as I said, for third level, you will get your hands on an SDR, which will be provided you by the hackathon team. But for level 2, it is not necessary. But I will still recommend you to buy some RTL SDR on your own, so that you can be well prepared. You will receive your confirmations shortly. So the registrations are still happening. So once the registrations are closed, you will immediately get a confirmation whether you have been eligible or not, and further tasks, or where you have to participate, which portal you have to log into. All of that details will be sent to you once the registrations are closed down. Level 2, again I'm explaining. Level 2, as I said, there will be virtual challenges wherein you are supposed to download a file, which will most likely be a capture file, which means that we have already captured the signals, or the challenges are already there in a file. That file, you need to know how to open it. So typically you should be using something like a Wireshark. Okay. Okay, I'm just pasting the Wireshark example over here. Wireshark is basically a packet interception tool. So it will let you open the intercepted packets. You will be able to study what kind of data that is present inside it, and based on that data, you will be able to understand what kind of decoder that is required. So there might be a requirement that you might to program it a little bit. I mean, there is no specific programming language as a requirement. Whatever programming language you are comfortable in, maybe you are required to write a program to automatically decode it. Otherwise, as I said, you can use GNU Radio, which can help you out in decoding a wide variety of signals. So a wide variety of signals can automatically be decoded by using GNU Radio. There are a lot of plugins that are available. So just make sure you are comfortable with GNU Radio. GNU Radio is the most important tool that you will use in both level 2 and level 3. So make sure you are comfortable with GNU Radio. A lot of tutorials and lot of plugin details are already available on the internet, as well as YouTube. So there are a lot of YouTube videos which are made on GNU Radio, how to work with GNU Radio. You will also be able to get a lot of hackathons which have been happening in the last 5-6 years. So there are a lot of data sets that are already available. So for example, let me give you a sample data set. Okay, I'm just presenting some papers here. You should actually. Yeah. So yeah, maybe just go to this link that I've pasted right now. You have something called as an access data set. See if you can download this data set, and you should be able to analyze this data set in a GNU Radio. Yeah. I'm not able to download this, but check. You should be able to download a data set from here. It's not big data. Yeah, there are a lot of CTF challenges that have already happened in previous. I'm just looking for some data sets which you can use. Yeah. You should be able to find some data sets once you. Yeah. So I'm just pasting you some links which can help you out with, where you will be able to find the data sets of previous hackathons that have been conducted across the world. So these are all actually intercepts. Yeah, I guess, if you just register over here in this particular link, I guess you will get access to the latest, access to this particular CTF data sets. So this data set will be similar to what you will face in the level 2. So I've pasted a lot of links. Please copy it somewhere so that you can check these links and download some data sets which can help you prepare for level 2. So that's about from my side. So if you have any queries, do let me know. Otherwise, we can log off. Yeah, you can also check DEFCON villages to see if you can download some data sets for SDR. The recording of this session will be available shortly, maybe in a day or two.
We will upload it in the YouTube site tomorrow, Karthik.
Okay, great. That's what. So in a day or two, you should get your recordings. Yeah.
Thank you, Karthik, for the amazing session.
Thank
And
you.
thanks,
Thank you, Shiva.
thanks to all the participants for joining us, and we'll meet again next Wednesday, same time. Thank you.
Yeah. Thank you. Thank you all.
Hello, ma'am.
Hello. Yes, who is this? Yes, Sriharsha.
Sir, I missed last week and that previous week's classes. How I should see those recording?
Harsha, it is uploaded already in our ISAC YouTube site.
Okay. In YouTube, we have to see that.
Yeah, YouTube.
Yeah,
all
yeah,
the
it's
sessions
all.
are
Yeah,
uploaded
it's
there.
available on the YouTube, so you can check it over there. And again, these are repeated workshops, which means the same thing that we have discussed last week, we are discussing it today. So it's fine. You can attend any of these workshops because these are repeated workshops. So it's not like a continuous workshop where we are discussing multiple things. These are repeated workshops, so don't worry about previous sessions.
Okay, sir. Thanks.
Okay. So then, thank you all. That's all for today. We'll be logging out now. Okay, let me paste you the YouTube link then. our channel where you can get it. Yeah, I've just pasted it. You can. Yeah, sorry. Okay. Yeah. So you can just go to this YouTube, or you can subscribe to this YouTube, and you will be able to find this subsequent sessions also on this YouTube channel. Great. So that's all for now, folks. Thanks everyone.